Okay class, so let's have binary number system. A binary number is made up of only zeros and ones. Okay, so example of a binary number, we have 1 1 0 1 0 1. So if you notice, there is no 2, 3, 4, 5, 6, 7, 8, or 9 in binary. Now each binary digit is called a bit. So in this example, we have 6 a bit. So let's now proceed with binary addition. So but before we proceed with that, let's have first the basics in binary numbers. So say for example, you are given 1 plus 1. So how do we add binary numbers? So in adding binary numbers, we have the following rules. So we have 1 plus 1, that is 0, carry 1, then we have to bring down 1. We said earlier that there is no 2, 3, 4, 5, 6, 7, 8, or 9 in binary. So whenever you have a 1 plus 1, that is actually 0, carry 1. So that is the first rule. Another is we have, say, 1 plus 0. So whenever we have 1 plus 0, we have here 1. And then if we have 0 plus 1, we have here 1. And of course, if we have 0 plus 0, the answer is 0. What about if we have, say for example, 1 plus 1 plus 1? So how do we add binary numbers? So the first thing you have to do is to look for a pair of 1 and 1. So whenever you have a pair of 1 and 1, that is 0, carry 1. Okay, then you have 0 plus 1, here you have 1, and then you have to bring down 1. So the answer is 1 1. But say you are given 1 0 1 plus 1 1. So how do we add these binary numbers? So we have first take the last digit, we have 1 plus 1. According to our rule, that is 0, carry 1. So we have here 1 0 plus 1. So this is a one pair of 1 and 1, so that is 0, carry 1. Okay, so we add now 0 plus 0, we have 0. We have another pair of 1 and 1, so that is another 0, then carry 1. Then we bring down 0, we bring down 1. So the answer is 1 0 0 0. Another example, say you are given 1 1 1 plus 1 0. How are we going to add this binary number? So again, we start operating at the right. We have 1 plus 0 is 1. 1 plus 1, that is one pair, so that is 0, carry 1. Then we bring down 0. 1 plus 1 is another pair, so we have 1 plus 1 is 0, carry 1. Again, we bring down 0, and then we bring down 1. So the answer is 1 0 0 1. Now, but we don't have any idea if our answer is correct. So unless we convert it into a number system which we are familiar with, we can check if this number is correct. To check if your answer is correct, we have to convert this binary number into decimal. But how do we convert binary numbers to decimal? So to do that, we are going to use the positional value. So we start with 1, and then 2, and then 4, and then 8, and then 16. So times 2 times 2 depends on how many digits we are converting. And then we put the number, the given numbers below the positional value. So in this case, we have 1 1 1. So to convert these binary numbers into its equivalent decimal number is to simply add the values in the positional value, which is opposite to one binary number. So say for example, 1 is opposite 1, 2 is opposite 1, 4 is opposite 1. So we need to add 4 plus 2 plus 1. So 1 plus 2 plus 4, that is 7. So in other words, 1 1 1 in decimal is 7. To convert 1 0, again we put the number here 1 0 since we only are using 2 digits. Okay, and then we add the number, and then we consider only the number which is opposite 1. So in that case, that is 2. So meaning to say, so in other words, 1 0 is 2 in decimal. So we're actually adding here 7 plus 2. So in decimal, when we add 7 plus 2, that is 9. Now let us check if this 1001 is equivalent to 9. Again, we put the number 1001 below the positional value, and then we only add the numbers of the positional value which is equivalent to 1 in binary. So we have here 1 and then 8. So we only add 8 plus 1. So in that case, that is 9. So therefore, our answer is correct. So as a recap, these are the rules that you need to remember in adding binary numbers. So first, we have 1 plus 1, that is equal to 0 carry 1. Then we have 1 plus 0 is equal to 1, 0 plus 1 is equal to 1, and 0 plus 0 is equal to 0. Now, let us proceed to binary subtraction. Now, how do we subtract binary numbers? So, say for example, you are given the numbers 1, 0, 1 minus 1, 0. So to subtract binary number, we start again operating at the rightmost part of the number. So taking the last digits, we have 1 minus 0. Of course, 1 minus 0 is 1. 0 minus 1 cannot be. So in this case, 0 will borrow 1 from 1. So if 0 will borrow 1 from 1, 1 will become 0. And 0 here will become 2. Now, why 2? Since we are in binary number system, each one borrowed is equivalent to 2. Okay? So, 2 here minus 1 is 1. So, that is 0. No need to bring it down. Again, in subtracting binary numbers, each one borrowed is equivalent to 2. Okay? Again, to check that, using the positional value, we have 101. So I'm going to write, let's say 1248. This is the positional value. So to check if our answer is correct, again, we need to put the digits below the positional value, and then we only add digits which are opposite 1. So we have 1 and 4. So 101 in decimal is 5. Okay. And then we have, so we are actually, this is actually 5. How about 1 0? So 1 0 is, so 1 is 2. So we have 2. So we're actually subtracting 5 minus 2, which should give us 3. That's our answer. So if you want to check if our answer is correct, we have to again put it again below the positional values, and then we add. So 1 plus 2 is 3. So meaning to say our answer is correct. Okay, so let's have another example of subtraction. Say for example you are given 1 0 0 1 minus 1 0. So how do you subtract binary numbers? Again, we start operating at the rightmost part of the given number. So we have here 1 minus 0. This is 1. We have here 0 minus 1 cannot be. So we have here trailing 0. So whenever we have 2 or more zeros, we call them trailing zeros. If you have trailing zeros, you start operating on the 0 that is nearest to 1. So in this case, the 0 which is nearest to 1 is this 0. So this 0 will borrow 1 from 1 first before this 0 can borrow from here. So this is the number, this is the 0 nearest to 1. So this 0 will borrow 1 from 1. So 1 here will become 0. 0 here will become 2. Since we know that, again, in binary subtraction, each one borrowed is equivalent to 2. So 2 now, So 0 here now becomes 2. So 0 now can borrow 1 from 2. So 2 will become 1 and 0 will become 2. Okay. So then proceed. 2 minus 1 is 1. And then we have to bring down 1. So to check again if our answer is correct, we need to use the positional values to convert our answer to decimal. So we have 1, 0, 0, 1. So we simply add 1 and 8. So that is 9. And then 1, 0, which is 2. So we are actually subtracting 9 minus 2, which is 7. So let us check if 1, 1, 1 is 7. So again, we put it 1, 1, 1. So since the 3 digits are 1, so we add 1 plus 2 plus 4, that is 7. So meaning to say our answer is correct. So as a recap, these are the rules in subtracting binary numbers. So we have 1 minus 1 is 0. 1 minus 0 is equal to 1. 0 minus 1 is equal to 0. Borrow 1, which is actually equivalent to 2. And then 0 minus 0 is equivalent to 0.